Hey guys, welcome back. In this video, we are going to cover Linux Fundamentals Part 3. So let's get started straight. Introduction. Welcome to the Part 3 of the Linux Fundamentals module. So far, throughout the series, you have got hands-on with some fundamental concepts and used some important commands. This room is going to showcase some useful utilities and applications that you are likely to use day to day. You are also going to advance your Linux full skills learning about automation, package management, and service application logging. All right, so let's start the machine here. You can access the machine attack box. So let's start the attack box here. Oh, we need subscription, so I think we need to log in by our VPN. So come here and where is it? Access, and you just download the VPN. Okay, so it will automatically select the server and download the VPN, and let's connect to the VPN. Let the server get started and we will connect to the VPN. Okay, so username is tryhackme and the password is also tryhackme. So let's mark this as completed and let's go to the next part until the machine is started. Throughout the series so far, we have only stored text in a file using a combination of a echo command and a pipe operators. This isn't an efficient way to handle data when you are working with files with multiple lines and the sorts. Introducing terminals text editors. There are few options that you can use, all with a variety of friendliness and utility. This tasking is going to introduce you Nano but also show you an alternative named Vim, which TryHackMe has a room dedicated to. Alright, Nano. It is easy to get started with Nano. To create a edit file using Nano, you just simply Nano file name, replacing the file name with the file name you choose to wish to edit. Once we press enter to execute the command, Nano will launch, where we can just begin to start entering or modifying our text. You can navigate each line using the up and down arrow key or start a new line by pressing enter on your keyboard. Nano has a few features that is easy to remember and covers most general things that you would want out of a text editor, including searching for text, copying and pasting, jumping to a line number, finding out what line number you are on. You can use these features of Nano by pressing Control key, which is represented by as an upper arrow on Linux, and a corresponding letter. For example, to exit we would want to press Control X to exit Nano. Vim. Vim is so much advanced text editor. You are not expected to know all the features. It is useful to mention that it's powering up your Linux skills. Some Vim some Vim benefits taking a much longer time to become familiar with it, which includes customizable. You can modify the keyboard shortcuts to be of your choosing. Syntax highlighting, that is useful if you are waiting or maintaining code, making it popular choice for software developers. Beam works on all terminals where Nano may not be installed. There are a lot of resources such as cheat sheets, tutorials, and the sorts are available to use. Try me as a room showcasing Beam if you want to. Alright, so let's start. Edit the task tree located in Hackme's home directory using Nano and what's the flag. Okay, so let's log in here. So let me clear the screen and let me go to download. I hope. Okay, CD or direct feedback and downloads. And yep, there it is, my configuration file named udemy course.openvpn. So I'm gonna just type here openvpn and the configuration file open udemy and just press enter here, and it has connected to the TryHackMe network. Okay, so open a new tab, and if you type in here if config, and you can see the turn 0, that is a try hack me your local IP on the try hack me network. Okay, so I'm gonna just SSH into try hack me at the rate our machine IP, which is 10.10.43.120, and let's see, press type yes, and the password is try hack me, and it should log us in. Okay, let's see. It should, I think it's lagging. Let me do it again. Okay, I think it lagged completely. Oh, oh, we just logged in and we just closed the connection. Okay. I think the server is lagging because the specifications are not that good. So try hack me. Let's see. Let it give time to log in. Okay. Let's see here what they used. You can see the commands like Control G at the upper arrow is Control G to get help, Control O to write output, Control W to queries, cut text, and all that. Okay, Control X to exit, Control R to read file, and we are logged in. All right, let's clear the screen first. ls. The name of the file is task3, and should press nano here. Task3. Just press enter. So it's thm text underscore editors. Thm text underscore editors. I hope my keyboard is not annoying, by the way. And let's start. Control X to exit and clear the screen again, and let's start general useful utilities. Downloading files. A pretty fundamental feature of computing is the ability to transfer file. For example, you may want to download a program, a script, or even a picture. Thankfully for us, there are multiple ways in which we can retrieve this file. We are going to cover the use of wget. This command allows us to download files from the web via HTTP as if you were accessing the file in your browser. We simply need to provide the address of the resource that we wish to download. For example, if I wanted to download a file named myfile.txt onto my machine, assuming I knew the web address, it would be something like this. Okay, wget and then the URL, transferring file from your host SCP. Secure copy or SCP is just that, a means of securely copying files. Unlike the regular cp command, this command allows you to transfer files between two computers using the SSH protocol to provide both authentication and encryption. Working on a model of source and destination, SCP allows you to copy files and directories from the current system to the remote system, copy files and directories from the remote system to your current system, provided that we know username and password for a user on a current system and the user on the remote system. For example, let's copy an example file from our machine to a remote machine, which I have neatly laid on the table below. The IP address, the remote system, the local file, and the remote file. Okay, so scp important.txt, ubuntu at the rate IP, username at the rate IP, and the file. And now let's reverse this and the layout of syntax using scp to copy from the remote computer to if you are not logged in. So this is copying file from remote computer to our computer, serving files from your host web. Ubuntu machine come pre-packaged with Python 3. Python hopefully provides a lightweight and easy to use module called HTTP server. This module turns your computer into a quick and easy web server that you can use to serve your own files, where they can be downloaded by another computer using commands such as curl and wget. Python 3's http.server will serve the files in the directory that you run the command, but this command but this can be changed by providing options that can be found in the manual pages. Simply, all we need to run Python 3-m http.server to start the module. In the screenshot below, we are serving the directory called web server, which is a single named file. So Python-m http.server. It will by default serve on the port 8000. Okay, so if you don't want, if you want to specify the port, you can specify after that. So http.server space and the port number, let's say 1234, and it will serve on 1234. Now let's use duplicate to download the file using your computer's IP address. And the name of the file. One flaw with the module is that you have no way of indexing. So you must know the exact name and location of the file that you wish to use. This is why I prefer to use Updog. What is Updog? An advanced yet a lightweight web server. Okay, so I'm gonna duplicate the file from the local server. This is downloading your own file, and you can see the web request from your local host, which is the IP here. So answer the question below. Ensure that you are connected to the deployed instance. Yep, we are connected. Now use the Python to HTTP server module to start the web server on a TryHackMe user and deployed instance. Okay, download the. Uh, let me show you how Python 3-m http.server. You can see that the server is started. Okay, so we can navigate. Let's see the. Let me see my IP here. Let's navigate to the machine here if we can, and you can see here catsanddogs.jpg is the current directory. Let's see here. We just started our web server, navigated to our IP, and we got the index. Okay, catsanddogs.jpg is the file present. Oh, there. So let me close by mistake, and let's try to download it. Download this file. So wget http 10.10.43.120 port 8000 onto slash dot flag. I don't think it will download because we need to start our web server first. Okay, yep, we need to start our web server, and the web server is started, and let's download it on our machine. Okay, so let's ls here and wget, just copy here this from here and just paste it here. So let's see, and the flag is downloaded. So cat dot flag, and it is the flag here. I just hosted a server, normal Python server that we just saw on the, as we are connected to the TryHackMe local network. So I just navigate here, type in the local network, uh, IP address, machine IP address, and we just get the file. Okay, so let's paste in the answer here. Create and download files in the further. Apply your learning. See how you can read the documentation of Python 3's http.server module. Use Ctrl C to stop the Python server module once you are finished. Okay, so you can press Ctrl and C to stop, and not even Python but any process. Okay, that is stuck or something. Just press Ctrl C and it will stop. Okay, processes 101. Processes are the programs that are running on your machine. They are managed by the kernel. Your kernel, each process will have an ID associated with it, also known as its PID. The PID increments for the order in which the process starts. That is, the 60th process will have the PID of 60. Viewing process. We can use the friendly ps command to provide the list of running processes as our user's session and some additional information such as its status code, the session that is running it, and how much usage time of the CPU is it using, and the name of the actual program or command that is being executed. Now, now in the screenshot above, the second process PS has a PID of P204, and then in the command below, it is incremented as 205. Okay, the process PIDs are incremented, and this is just saying here to see the processes run by other users and those that don't run from a session, that is system processes. We need to provide aux to the ps command like so, ps aux. So note that we can see the total of 5 processes. Note how we now have root and semantic processes. Another very useful command is the top command. Top gives you real-time statistics about the processes running on your system instead of a one-time view. These statistics will refresh every 10 seconds, but will also refresh when you use the arrow key to browse the various rows. Another great command to gain insights into your system via top command. Managing processes. You can send signals that terminate processes. There are a variety of types of signals that correlate to exactly how cleanly the process is dealt with by the kernel. To kill a command, we can use the approximately named kill command and the associated PID that we wish to kill. That is to kill PID 137 with use kill 137. Below are some signals that we can send to the process when it is killed. Sigtum kill the process but allow it to do some cleanup task beforehand. Sig kill the process. The door doesn't do any cleanup after the fact. Sig stop or suspend a process. How do processes start? Let's start off by talking about namespaces. The operating system uses namespaces to ultimately split up the resources available on the computer to such as CPU, RAM, and priority processes. Thinking of it as splitting your computer into slices. Similar to the cake, processes within that slide will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Namespaces are great for security as it is a way of isolating processes from another. Only those that are in the same namespace will be able to see each other. We previously talked about how PIDs work, and this is where it comes into play. The processes with an ID of 0 is the process that is started when the system boots. This process is the system's unit on Ubuntu, such as system D, which is used to provide a way of managing a user's process and sits in between the operating system and the user. For example, once a system boots and it initializes system D is one of the first process that is started. Any program or piece of software that we want to start will start as what's known as child process or system D. This means that is controlled by system D but will run as its own process. To make it easier for us to identify the likes, getting processes and services to start on boot. Some applications can be started on boot of the system that we own. For example, web servers, database servers, and file transfer servers. This software is often critical and is often told to start during the boot up of the system by administrators. In this example, we are going to be telling the Apache web server to be starting Apache manually and then telling the system to launch Apache to on boot. Enter the use of systemctl. This command allows us to interact with the systemd process daemon. Continuing on with our example, systemctl is an easy to use command that takes the following formatting: systemctl, options, and services. For example, to tell the Apache to start up, we'll use systemctl start Apache. Seemed simple enough, right? So same with if we wanted to stop Apache, we just replace the option will stop. So we can do four options with systemctl: start, stop, enable, and disable. An introduction to background and foregrounding in Linux. Processes can run in two states, in the background and in the foreground. For example, commands that you run in your terminal, such as echo, on the things that sort of run in the foreground of your terminal, as it is the only command provided that hasn't been told to run in the background. Echo is a great example, as the output of echo will return you to the foreground, but wouldn't in the background. Take the screenshot below for example. Okay, echoing the high THM string, high echo, high, it ran in the background, high THM, right? Here we are running echo high THM, where we expect the output to be returned to us like it is at the start. But after adding the AND operator to the command, we are instead just giving the ID of the echo process rather than the actual output, as it is running in the background. This is great for commands such as copying files, because it means that we can run the command in the background and continue with our further commands we wish to execute. We can do the exact same when executing things like scripts rather than relying on the operator, and we can use Ctrl plus Z on your keyboard to background the process. It is also an effective way of pausing an execution of the script command like the example below. The script will keep on repeating. This will keep on looping until I stop the process by using Ctrl Z. Now our terminal is no longer filled with messages until we foreground it, which we will discuss below. Foregrounding a process. Now that we have a process running in the background, for example, our script background.sh, which can be confirmed by using a psaux command, we can backpedal and bring this process to the foreground to interact with our process as background using either Ctrl plus Z and or the AND operator. We can use Fg to bring this to focus like below, where we can see the Fg command is being used to bring the background process into use on the terminal, where the output of the script is now returned to us. Fg, so we just foreground it. Okay, let's start. Let's answer the questions here. If we were to launch a process where the previous ID was 300, what would be the new process? So we just saw the process ID will be incremented by 1, so next process will be 301. If we wanted to cleanly kill a process, what signal we send it? So it's seek term, as it gives the time to the process to do some cleanup. Look at the process that is running on the deployed instance. What flag is given? Okay, so let's see ps. Let's type in ps first. So ps aux command. Okay, there are so many processes. I think we need to find our flag here somewhere. Let's see if we can find. I think it should have some prefix with thm. Let's see. Oh, there it is. Thm processes. Okay, so let's copy selection here and paste it here. Yep, that's correct. What command would we use to stop the service my service? So system ctl stop, and the service name is my service, so my service, and submit. Yep, that's correct. What command would we use to start the same service on the boot up of the system? So if we want to start on boot up, so systemctl enable my service. Let's type in. Yep, that's correct. What command would we use to bring the previously backgrounded process back to the foreground? So that fg And that's correct. All right. So let's go maintaining your system automation. Users may want to schedule a certain action or task to take a place after the system has booted. Take for example running a command backing up files or launching your favorite program on, such as Spotify or Google Chrome. We are going to be talking about the cron process, but more specifically how we can interact with it via use of cron tabs. Cron tabs is one of the processes that is started during boot, which is responsible for facilitating and managing the cron jobs. A cron tab is simply a special file with formatting that is recognized by the cron process to execute each line step by step. Cron tab, cron tab requires six specific values: minute, hour, day of the month of the year, week of day of the week, and the actual command that we wish to execute. Let's start with the example of backing up files. You may wish to back up semantic documents every 12 hours. We would use the following formatting. Okay, every 12 hours, so specified hour to execute CP. It's copying the command dash R for recursive documents and pasting it in var backups. An interesting feature of cron types is that this also supports a wildcard or asterisk. If we do not wish to provide a value for that specific field, if we don't, that is, we don't care what month, day, or year it is executed, only that it will, only that it is executed every 12 hours, we simply just place an asterisk. This can be confusing to begin with, which is why there are some great resources such as the online cron type generator that allows you to use a friendly application to generate your formatting for you, as well as cron group. Okay, these are some external websites. Cron tabs can be edited by using cron tab-e, where you can select an editor such as Nano to edit your cron tab. Okay, this example. So when will the cron tab be deployed on the instance run? So let's try here cron tab. I think it lags. So let's see here cron tabs. So cat. So with cron, no cron. So let's cat the cron tab here and we get something. Let's see here. Let's see. Unlike the other, when will the cron tab on the deployed machine instance run? So I think it will run on a reboot. So, let's see here. Cron tab. Okay, so let's see here. Cron tab, hourly, weekly, daily, cron tab. So let's cron dot d. Let's go to the folder cron tab dot d. No, I think it should run on a reboot. Okay, as far as I see here. Let's see. Let's try here reboot. Enter. And yep, that's, I mean that's running on reboot. So let's try even this cron type dot e that we just saw. You can see the cron tab and you can see here, right? Reboot, where output and processes.sh will run on a reboot. Okay, clear the screen and let's go to the next, maintaining your system package management. Introducing packages and software repos. When developers wish to submit software to the community, they will submit it to an app repository. If approved, their program and tools will be released into the wild. Two of the most redeeming features of Linux shine to light here: user accessibility and the merit of open source tools. When using the ls command on the Ubuntu 20.04 Linux machine, these files serve as a gateway registry. Okay, these are the registries. Operating system vendors will maintain their own repositories. You can also add community repository to your list. This allows you to extend the capabilities of your operating system. And additional repositories can be added by using the add app repository command or by listing another provider. For example, some vendors will have repository that is closer to their geographical location. Managing your repositories, adding and removing. Normally, we can use the apt command to install software onto your Ubuntu machine. The apt command is a part of package management software, also named apt. Apt contains a whole suite of tools that allows us to manage the packages and sources of our software and to install or remove software at the same time. Let's walk through adding and removing a repository using a add apt repository command illustrated above. You can install software through the use of package installers such as dpkg. The benefits of apt that whenever we update our system, the repository that contains the pieces of software that we add also gets checked for updates. In this example, we are going to add the text Sublime text to our Ubuntu machine. And as the repository, as it is not part of the default Ubuntu repositories, when adding software, the integrity of what we downloaded is guaranteed by the use of what is called GPG, GNU Privacy Guard keys. These keys are essentially a safety check from the developer saying, here's your software. If the keys do not match up to what the system trusts and what the developers use, then the software will not be downloaded. So to start, we need to add a GPG key for the developers of Sublime Text 3. Note that TryHackMe instances do not have internet across. So we are not expecting you to add these to the machine that you deployed and it would fail. Okay, so you should download the GPG key here and add the key in the repository. Now that we have added the key to our trusted list, we can now add Sublime Text Tree repository to our sources list. A good practice is to have a separate file for every different community third-party repository that we add. Let's create a file named sublime text.list in hcappsources.list.d to enter the repository information like so. And now we use Nano text editor we use Nano or your text editor of your choice to add and save the Sublime text repository to the newly created file. After we have added this entry, we need to update app and recognize the new entry. This is done by using apt update command. Once you successfully updated, we can now proceed to install the software that we have trusted and added to app using apt install Sublime Text. Remo- Removing the package is easy as reversing. The process is done by using the add app repository slash remove and the name and slash the program command or by manually deleting the file of the previous full feed. Once removed, you can just use apt remove software name, that is apt remove sublime dash text. Okay, so we are not going to install it. We just, that was just for uh, example demo purpose, we briefly touch upon log files and where they can be found in Linux Fundamentals Part 1. However, let's quickly recap located in the var log directory. These files and folders contain logging information for application and services running on your system. The operating system has become pretty good at automatically managing these logs and the processes that is known as rotating. I've highlighted some logs from three services running on Ubuntu machine. Apache 2 web server, logs for fail to ban service, which is used to monitor attempted brute force, for example, the UFU service, which is used for as a firewall. These services, so let's see what they did. So they just listed, so let's try ls slash var slash log, and yep, that's present. These services and logs are a great way in monitoring the health of your system and protecting it. Not only that, but the logs of for a service such as a web server contains information about every single request, allowing developers or administrators to diagnose performance issues or investigate an intruder activity. For example, the two types of the log files below that are of interest, access.log and error log. These are of course logs that store information of how OS running, how is the operating system running itself, and action that are preferred by users, such as authentication attempts. So look for the Apache 2 logs on the deployed machine. So Apache 2 log, think it should be there. Yep, that's Apache 2. So if I cat Apache, I think that's a folder. Let's see, cd Apache. APSCHU2, let's try catting it, concatenating it. I mean, what type of file is it actually? Okay. Oh, I just made a mistake. I mean, I just did some embarrassing stuff. So let's change the directory first, ls. So I'm gonna see here Apache. There are Apache logs, Apache 2 logs, error logs. What is the IP address of user who visited the site? So we're gonna cat access log. No? Oh, let's see what are the permissions. We can cat the access.log.1 and error.log.1. So cat access.log.1, and this is the IP 10.9. Let's copy and paste the answer and press enter. Yep, that's correct. What file did they access? So they get the request for cats and dogs.jpg. Okay, copy, paste, and yep, that's correct. I think that completes our Linux fundamentals part 3. And from okay, let's mark this as completed and also terminate the machine. Okay, so this marks the complete of our 3 series of Linux fundamentals by TryHackMe. So in the next video, we are going to start over the wire bandit series for Linux, capture the flag for practicing Linux commands, very basic Linux command, some intermediate stuff, and also some advanced stuff. Okay, so I think that's all for this video. I hope you enjoyed. See you in the next video. Bye.